We are continuing the 4-7 sequence notes in your yellow notepad. We're on page 4. And as we continue, we're on the bottom half of that. And it says, consider this formula. T of n equals 15 plus 2 times n minus 1 for all integers that are greater or equal to 1. Well, what are the first 4 terms first in our formula? So what we need to do to solve this is term 1 is we want to use our formula above, 15 plus 2, and if it's our first one, that means we're replacing the n with a 1 minus 1. So our formula would be 15 plus 2 times 1 times 1 is 0. So the first term should be term 1 is equal to 15. We now want to look at our second term of this sequence. In our second term of the sequence, we're going to use the same formula, 15 plus 2, but we're replacing the n again up above with a 2 minus 1. So we have 15 plus 2 times 1. Our second term is equal to 17. If we continue with this, I would like you to right now find the third term and find the fourth term and the eighth term, t of 8. So again, you're going to use the formula, and I'd like you to pause the video at this point and do this formula. If you pause it right now, then when you come back, you should see that formula filled. Check to see that you got the same answers for term 3, term 4, and term 8. If you need to pause it to look at the work, please do so. We now want to take a look at the next table, and it says consider the t of a sequence of consecutive positive integers. Complete the table for each term in the sequence of squared numbers. So think about your square numbers, and if we are filling in our square numbers, the first square number term is 1, 2 squared gives us 4, 3 squared 9, 4 squared 16, 5 squared 25. Please complete the rest of the table. Pause it if you need to. And then our last one down here should be n squared. And the question says, well, what is the 250th term? Well, the 250th term is going to be equal to n squared, or 250, and we are going to square that, which gives us a value of 62,500. On the bottom of the next page, again, we're looking at a sequence, and it says, look at the following table for analogies. If we look at our function notation, we might have the independent variable x. We write it as f of x. When we talk about our t, we have the independent variable n, term n. So it says, which of the explicit formulas is the formula for the nth term? And again, what you really want to do is plug in your values. We can see that it looks like this first one, if we're looking at a common difference, it's first, if we are looking at it, 3. The next one has a common difference, and we're adding 5 and adding 7. So the pattern isn't right away standing out to us. If we look at the first term, does it work for this first one? We're going to substitute in 1, and it does work. The first term is 3. How about the second term? Can we take 3 times 2 to get our second term? Yes, it works for that too. Term 3, it looks like this one might be working, but here's where it doesn't work. 3 times 3 gives us 9. Our third term is 11, so we cannot use this one. We now want to try this next one, t of n. Part B says I should take 2 times 1 plus 2. 2 plus 2 gives us 4. Right away doesn't work in the first term. It looks like this should be our solution. T sub 1 gives us 1 squared plus 2. 1 squared is 1 plus 2. That works. Term 2, we're going to fill it in. We're going to put in 2 squared plus 2. 4 plus 2 gives us 6. What I would like you to do is check term 3 and term 4 and see if you think this is the one that's going to work. Pause the video and show that work right now, substituting in. You should now see term 3 and term 4. Hopefully you have the same thing. As we continue in this video, we are now looking, using our calculator can do a sequence for you. So if you enter the following key sequence in your calculator, and this is any scientific 2 plus 5 and hit equals. Then if you press the plus 5 again and hit equals, one more time, you should continue hitting enter. You should enter this, get this sequence, 7, 12, 17, 22. So it asks you now, could we write a key sequence for getting 40, 20, 10, 5, 2.5. If we think this is our first term, our second term, our third, our fourth, and our fifth term as we continue. Now, I want you to think about this a few minutes. There's a couple of different ways of coming up with this. The easiest one is whatever the first term is. What does it look like we're doing to get the second one? I think a lot of you will see this, that it looks like we are taking the term n, and we are taking it times half of whatever was before it. So half of n. So if we're looking at term 1 was going to be, if we are looking at that, and when we start this out, a lot of times we're going to think of it as terms 1 is 40. So we're always taking, if we want to think about this, half of n. Another one that someone said to me is we were thinking about this is, couldn't you say, Mrs. Thompson, that we're taking the first term and we're minusing half of it? That would also help us out. So we want to give our rule. As we're giving our rule again, we want to think about this. If we have 40 minus half of 40 is 20, or just half of 40 is 20. So we want to take a look, give you the rule for the nth term related to one or more of our previous ones. Now, this next page is going to show you a little more how they did that. Here was our sequence, call it a recursive sequence, a recursive formula. We put down our term 1 and then t sub n. And it says the previous term. So notice when we put this up there, we kind of wanted to say something about half of n or n times a half. We want to use this notation to help us out. T sub 1 is 40 times the previous. How do we show previous? Well, if this is n, the term before it would be n minus 1. You'll always notice it'll say usually integers for n greater or equal to 2, or it might say where n is greater than 1 for all integers. If it's all integers greater than 1, remember the first integer greater than 1 is actually 2. The first term is known, each term is generated by the previous term. An example, for the, if we're asked to evaluate the first 4 terms of a sequence defined by this recursive formula. The first term is 25. To find the nth term, that means we're going to take t of n minus 1, which is the previous term, to n, and minus 4 for the integers through 1. So what I would like you to do right now is we want to think of what does our sequence look like? It's going to have 25. We now want to find t sub 2. Well, that means t sub 2, the second term, has to be always using term, in this case, n minus 1. What is our n? Well, ours is 2 minus 1, and then we subtract 4. So we're actually taking term 1 minusing 4. Well, what is term 1 minus 4? Term 1 was 25. 25 minus 4 gives us 21 for our second term. What's our, and what I'd like you to do is pause the video right now and try the third term. If we do that, again, we're looking at the second term minusing 4, the previous one. 21 minus 4 gives us our next term of 17. So T3 is equal to 17. Please right now do term 4, and if you would do term 5, and pause the video. You should have your sequence completed with the numbers I had filled in. If you need to pause it, feel free to. We are now given this next example, and it says given the sequence 1, 8, 27, 84. What is the value of T3? Well, T3, that should be 27. What's T sub n? 1, 8, 27. Anyone see a pattern? If we look at that, that's actually taking n to the third power. So what would our 30th term be? 30 to the third power, which gives us, user calculated, 27,000. Now we want to look at microbes, and the nth generation is given in an explicit formula. P to the n equals 500 times 2 to the n minus 1. How many microbes are in the first generation? Again, if we are looking at this in our first generation, we want to take 500 times 2 times 1 minus 1. Well, that's simply going to be 500 times 2 to the 0 power. But anything to the 0 power is actually 1. So this means 500 times 1, which gives us 500 in our first. If we now want to take a look, how many in the fifth generation, we're going to use our formula, P sub 5 equals 500 times 2 times 5 to the 5 minus 1 power. 500 is equal to, or times, 2 to the 4th. Please put this in your calculator and check it out. We have 2 more flip charts to look at to get this ready for you to go on to all of your homework for this lesson. Using that answer key on your graphing calculator, you can also generate a sequence. So here's one. T1 is 10. If we are looking at 2 times the answer minus 5, and they tell you exactly how to put it in on your graphing calculator. Clear the screen, type 10, then enter. Type 2 times the answer minus 5, then enter, and continue to generate the next 5 terms. It is very key that you kind of take a look at where is this ANS. That is, in order to get to this key on your graphing calculator, you have to hit, if you notice, on the second key, and then it's kind of above your subtraction. So continue to do this to generate the sequence. And if you don't have a graphing calculator, we will do this in class tomorrow. With your graphing calculator, we'll do that in class. But what if you didn't have a graphing calculator and you just wanted to do this? If this is -4, 2 times the answer plus 3. If we wanted to look at that sequence, remember to get term 2, we know what term 1 is. Term 2 is actually going to be equal to 2 times the answer, which is our -4, our previous term. So this is kind of like saying t to the n minus 1, and now we're going to add 3. So we have -8 plus 3. -8 plus 3 is going to give us our next number in our sequence, which in this case should be -5. What is term 3 going to be? Term 3 is going to be 2 times the previous, -5 plus 3. So we have -10 plus 3. Our previous one, next one is going to be -7. I would like you right now to compute T4 and T5 while the video is paused. Notice I listed the next 2 terms. If you need to pause the video, you could then write out our sequence. It's -4, -5, -7, -11, -19. And there is a pattern. In this last example, as you are taking a look, oh no, kind of hit a wrong button on my part. On the last example, it says you have 2 more examples. To repay this $200 loan, you want to make $20 a month payment. At the end of each month, you receive a payment telling you how much you owe. Make a list of outstanding debts for the first 6 months. Well, if you want to think of this, term 0 is actually 200. But what is term 1? That's after our first payment. We've subtracted 20, so that's 180. Term 2, I would like you to find term 2 through term 6. So if we continue going down here, I would actually like you to do term 3, term 4, term 5, and term 6. And then if we think about writing our formula, remember, we want to put T of 1, which is our 180, is equal to T of n, which is the previous term, n minus 1, minus 20, where n is greater than 1. I want you to read through this and try and generate the first 5 terms and write the formula. Remember, the recursive formula has to have a t to the 1 and a t to the n. Good luck. We'll look at that in class tomorrow. Here's the pattern I started. Take a look at this. We'll finish it in class.